All right. Welcome back. Day 6. It's the start of the PM session. We're moving right along with the schedule. Now we covered already the recap from week 1. Remember, we made the playlist available so you can go back and rewatch any of the portions, either that you missed or one that you want to rewatch to get an idea of the type of work that any of the particular faculty are doing. And then that leads obviously directly into choosing a project. We covered that. I have these kind of 4 broad projects outlined, and you can choose one of those, or we can continue discussions and try to work out something else that works a little better for you. Uh, and then we're going to keep going here with this re-examination of the urban heat island and a couple of new concepts that it brings into play. But before, I just want to point out again some other opportunities that are available to get involved in different projects with KSU. So as I mentioned before, I'm half of my time is spent being an extension agent, and this is where we do community outreach and work either with young people and try to get them involved in science and learning, or working with small farmers and land managers who are trying to apply science into their business. And uh, aside from what I'm doing here today with you all, we have several other professionals that dedicate their entire time to kind of serving in this niche, and broadly that all falls under 4-H youth development. So you can just Google KYSU 4-H development, or even better 4-H youth, right? And you'll get to this page. All right, and this is where we're looking at, and pretty much everything that's to offer, the SAP should be on here somewhere. These are other opportunities, and a lot of these are also connected to stipends. So some of these have rewards where they, they compensate you in some way for taking part, and they also create opportunities and trips and stuff, just like we have here. Um, and the one I want to point out to that, so ag discovery is going on and already, and it's like exclusively agriculture and stuff. And there's this other thing. So you were supposed to hear earlier about the 1890 Scholars Program and a little bit about how that works at KSU. But as I had mentioned, there's multiple programs that are at the same level and ultimately from these same funding sources. And these are other programs that try to get you involved, right? Because it's about being involved, and that's how you find out where the opportunities are. And the scholarships are some of those opportunities. So for this year, they have this thing called the STEM Scholars Academy. And it's in some ways like what we're doing here, whereas the intent is to expose you to the different areas where applied STEM scholarship is happening, right? Because it drives into research and then drives into extension, which is where it actually begins to help the community. And so what do they have? They have like virtually monthly mentoring sessions. So you really, if you were to choose one of these areas that we've demonstrated already, here's still yet another program that kind of serves as a continuation of that, right? And this is more 4-H, and this is Dr. Travella Free, and she's like the director of kind of the whole 4-H program as it is, and all these things kind of fall under that. And then there's this other really important thing that I actually don't see listed on here: tech change makers. Because I found it on the national site. But this is all about learning the skills that are related to social media. Okay, so you all know that apps have taken over the world, and the way that apps spread are through people's networks. Okay, and the manifestation of that is the social network slash media, social media, right? So That's how things spread. So when you want to get your point across, or you want to advocate for anything, all right, either some kind of change or some kind of particular projects, you can magnify your voice many times over, okay? And this is connected to a certain issue because not everybody actually has access to internet, especially in Kentucky, in East Kentucky. Um, and we're actually going to look at East Kentucky just here in a second. And so this is all about trying to advocate for that issue to try to increase the access to broadband and internet connectivity, but then also develop the skills to bring this power to bear on the type of problem solving that you end up doing. So they are really pushing this program a whole lot. So if you're interested in learning more about this, you can either go directly, to the 4-H Tech Change Makers, or you can just, reach out to me and I'll share more about that with you. All right, bringing us back to what's on the schedule. All right. So when you came to campus, we talked about what the urban heat island was, and we looked at it. And we're just briefly going to review those portions today, just to get it back fresh on your mind. But then we're going to go a little bit further. And remember, this is within the context of a proposed project, that's related to the type of work that I do in terms of environmental monitoring. Now, we've talked in depth about monitoring the earth, watching the plants change, watching the water come and go. But what's absent from that whole thing has kind of been the social part of it. So the people. And to prove the point, when you look at Google Earth, a lot of times the people have totally been removed. So oftentimes we don't really think about that part of the problem, right? But it's really the foundation of why we study the problems and all. And with all this stuff about the urban heat island, you may have asked, how is it that this is a problem? If this is something that's observable, and urban heat island kind of takes place in all the places, and if there's all these negative externalities from it, if there's all these bad consequences that can come from it, how is it that we're in such a place where that's the issue, right? Why is that the case? So the agenda briefly for this series that we're about to go through is, as I said, we're going to review the urban heat island just to get it back in your mind, and then we're going to define this new term that you may or may not be familiar with, but it is ferociously important, and every day it's becoming a bigger deal. And as I mentioned earlier, the education department is meeting today to figure out how to bring this to the inside, right, to the forefront. And here I'm defining environmental equity, okay? But this falls within the context of what traditionally was known as environmental racism, and more recently is fallen under the broader umbrella of critical race theory. Okay, now, and I'm not trained in critical race theory yet to be able to really talk a lot about the philosophical parts of that, but what does that look like in terms of monitoring the environment, right? And so we're going to explore some examples of what that looks like, and then by the end of it, I'll get to proposing what my project would look like, that I'm inviting anybody on, anybody who's in the program and wants to look at this problem through this lens. We can explore this together. And remember, as always, it's about serving people, right? Creating opportunities and experiences, and making sure everybody is safe and healthy and prosperous. So remember what the urban heat island is. Okay, the urban heat island is increased air temperatures in an urban environment compared to the surrounding rural side, right? the countryside. And and the other day we looked at a lot of maps that showed land cover distributions, and land cover is exactly what you see here along the x-axis. What kind of stuff is on the surface of the earth, right? So out in the country, it's a lot of trees, open fields, farmland. As you move in closer to a city, you get the suburban residential slash commercial areas where there's malls and strip malls and a neighborhood after neighborhood and lots of streets and side streets and alleys and everything. And as you move to the downtown and airport areas and urban commercial areas, it's just solid pavement and concrete, solid pavement and concrete. And the impact of that is that you've replaced the natural vegetation, right? The natural habitat, the natural materials, the moisture, all of that that was there, and replaced it with impervious materials, right? So we talked a little bit about the flooding that that can create because the water can't penetrate down and get into the earth to be absorbed, to be soil moisture. Uh, and on top of all this infrastructure, we have all these machines and air conditioning and refrigeration and automobiles and other transportation and electricity generation that generates a lot of heat, right? And a lot of carbon dioxide and a lot of all kind of nasty other chemicals that are all greenhouse gases, right? And they just kind of create this big cloud of pollution over us, right? And on top of that, the urban morphology, just the texture, the general nature of the buildings, just being a big pillar of emitting long wave infrared, heating up the air even more, right? And never cooling down. And that's really the dangerous part of it, the urban heat island. It's hotter in the city. And at nighttime, this can be a really big problem because the body doesn't have an opportunity to cool down. And we talked about people that have studied this over time using satellite data and using meteorological station data. You can track the difference between the inner urban area versus the rural area, and you can measure it over time. So we have data that goes all the way back to 1900 or so. So you can see over 100 years, if you choose, what exactly has been taking place. And this map here shows the distribution of change. So the red dot, blue dot equals a positive or negative change, over the decades. And you see a lot of blues in here, and a lot of these are your cities that have been shrinking over time, the Rust Belt areas we talked about. And the places that have grown are the places that have seen a lot of population increases over time. So it's simply as the place gets larger and there's more city stuff happening, it's going to be hotter, all right? And we discussed and we did a hands-on activity even that explored to what degree land cover was the manifestation of that. So everything that we do in an urban environment, all the decisions that we make, everywhere we decide to put houses or to put factories or to put malls or to put whatever, that's all a function ultimately of the land cover. And that can be easily quantified and mapped as is done here, right? So you clearly see all that red and pink, that represents urban development. And the green and yellow around the outside is natural, either forest or farmland or open field or something like that. So if you look at this image on the right, that's the long wave infrared that's emitted from the earth, okay, as a function of its internal temperature. The surrounding areas, they're in the blue, right? And this is a C scale, so this is, I don't know how, this is probably about 85 or so, maybe closer to 90. And then the highs, in where the city's at, in where the red urban development is, it's 15 degrees Celsius higher, right? This may be 95 or 110 for the day, right? Extremely high temperatures. For some reason, the date is not on here. I apologize for that, but it's definitely a summer day here. And then this On the right is the same type of image, just very much zoomed in. So this was actually taken from an airplane at nighttime. So it just is a zoomed in version of where you can see, in a very clear way when you change from one kind of surface to the next, what, how different the heat signature can be. And the point here is to remember that this is a nighttime image, right? So this, the sun's not even out right now. It's at nighttime, and this is just energy that's been retained during the day. And these places that are especially cool, those are either trees or mitigation efforts like cool roofs, either white painted roofs that don't absorb a lot of heat during the day, or actual vegetation that's placed on top of there to take the place of the natural transpiration that would be taking place in a forest or a field, that has moisture in it if it were there. Okay. So our hands-on activity actually had you go around campus and you were actually measuring different land areas. And we got a good sense of how hot the pavement was versus how hot the field. I guess grass was the other option. And then we had some synthetic materials out there that were measured. If anybody wants to share any of their examples or share any of the temperature readings they had, that would be interesting too. All right, so what is that all leading up to? All right, so this is an environmental issue, the urban heat island, and we know that it impacts um, populations, right? We've heard that during heat waves it even has the potential to kill people. And uh, so, how is it then that comes to be, right? Well, it's recognized today, right, as an issue of environmental injustice. Okay, so what does that mean? All right, environmental justice means that everybody's treated fair and everybody's involved in the implementation of new ideas. Okay, anything a city decides to do, it needs to be fair and meaningful for the greatest amount of people possible, right? But there's a second part of that. Second part says, in spite of anything, no group of people can bear a disproportionate share of the negative consequences that result from any decision. Okay, no group can disproportionately bear negative consequences. All right, and we hear a lot about this in every issue. I'm introducing it here at Urban Heat Island. All right, and we're about to watch a short video in 5 minutes. A really wonderful video that will talk about environmental equity within the context of the Urban Heat Island, and it'll answer the question about how it is that this came to be. In fact, I need to. Right? That's the question. How, why is it like it is? That you should always ask that, because we have to understand how how the problem came to be in the first place, so that we can really start to understand how to efficiently mitigate or reverse damage, or however you want to look at it, but ultimately to make life better for more people. Okay? So let's look at this, keeping this question in mind. How do we get to a place where what's in our environment is hurting us, all right, in any capacity? So let's check this out. Let me just make sure I'm sharing sound.
As you move through a city, you probably notice summer heat can be a lot worse depending on which neighborhood you're in. Take these two parts of Portland, Oregon, Lower Albina and Council Crest. They're about 3 miles apart. One neighborhood has lots of trees and a great view of downtown, while the other sits next to the interstate and gets up to 19 degrees hotter. This isn't exactly a coincidence. Many of the neighborhoods that get hit by the most extreme heat today can actually be traced back to racist city planning policies from nearly a century ago.
When we studied 108 cities across the country, we found a systematic pattern that the redline communities were today, on average, about 7 degrees hotter than their non-redline counterparts.
Redlining was the government-sanctioned effort from the 1930s to segregate communities of color by refusing to give them housing loans and insurance.
There were already lots of racial covenants that neighborhoods would basically say, we are not going to allow Negroes, I think was the language, Chinese, Japanese, Hindus in these neighborhoods. And redlining kind of codified this, where now it was allowable.
The federal government rated housing desirability on 4 tiers. The lowest was graded Z and colored red.
They were not provided green spaces, they weren't provided street trees, they weren't provided a lot of investments that many other neighborhoods received. And so a policy that had played out 80 years ago was affecting what you and I would experience in our neighborhoods today.
Maybe you've heard of the urban heat island effect, where cities are significantly hotter than surrounding areas. Urban areas with roadways, asphalt, and large buildings turn solar radiation into heat. These features absorb the heat from the sun during the day. In the evening, when temperatures are supposed to cool down, the retained heat is released back into the neighborhood. Redline neighborhoods were more likely to be slotted for freeways, while green-coded neighborhoods were more likely to be given parks. Here's what that means for cities like Portland. You can see hotspots near highways and pavement, while trees west of the river keep things cool. Portland was actually the most extreme example of all the cities studied.
These areas have not had any interventions to change the neighborhoods since that period.
One of those formerly redline areas is Lower Albina, a historically black neighborhood. In the late 50s, the city of Portland flattened 30 acres from the neighborhood to make room for a stadium and parking lots. A few years later, the state bulldozed through the heart of the neighborhood to make way for the freeway, demolishing more than 300 homes. This led to a massive decline in what was once a thriving black community.
In Portland, because we don't have the Confederate history, we do have these monuments that engender the same kind of imposition of power that Southern Confederate monuments do, and the freeway is one of them, certainly I-5, and the other is the Memorial Coliseum. That's our Robert E. Lee statue.
This is Rukaya Adams. She grew up in the Albina neighborhood and chairs a nonprofit called Albina Vision, a group that's working to repair the damages done to the black community of Portland's Albina neighborhood. Albina Vision has proposed a plan to redevelop the area, lighting the interstate, building affordable housing, and pushing for large-scale urban green spaces to cool the city. Meanwhile, the Oregon Department of Transportation has proposed expanding the I-5 freeway further.
We do not agree with the direction it's going. We don't think that's the right way to heal the community and rebuild it. Because we were so intentional in destroying black communities, we must also be intentional in rebuilding them.
Lower Albina, like a lot of redline neighborhoods in Portland and elsewhere, has gentrified. Interstate construction decimated the population, but it's bounced back over the past few decades.
The discussion about Harriet Tubman Middle School and the safety of the air for kids is a major issue now. That even creates a point of tension, right? So as we talk about I-5 today, a lot of black folks are frustrated because they're basically saying environmentalists didn't care about the health of black children when it was all black, but now they care when their kids are there.
As climate change accelerates and we race to solve it, cities will continue to change exponentially. And with renewed calls for racial and environmental justice, solutions should include those who haven't had a say in the planning process.
It's a little easier more recently now that we're talking openly about systemic racism because we're beginning to identify the ways that it plays out in the urban form. I'm hoping that over time it will start to reflect a more equitable view of how we should all live in the city. But I just hope that by the time we get to that conversation, that neighborhoods aren't so gentrified, that there really are very few people of color, and the ones that remain there are the ones that are relatively privileged.
Okay, so that video, you know, it points to exactly a culprit. And remember, because the city and the infrastructure and the facilities that we need to handle our waste, they, that we don't just willy-nilly put them anywhere, right? You don't just put these things wherever you want. There's a process and there's people involved, and every city, in fact, has a department whose job it is to decide where these things go. All right. And for the folks from Louisville, Louisville is really at the forefront of this action. The reason I really like that particular video to show you was because it exactly spoke to our problem. It pointed out this question that we had about, how exactly does this distribution that's problematic come to be? And then, so that kind of starts to point to what the solutions were. And the end of that video offered a couple of them by showing examples of some of the redevelopment that was happening. Everything was green and leafy and all. And that action's relatively new, but it's really addressing older problems. Portland, Oregon, for better or worse, is among the most progressive of all the models out there for what this can look like. And I know if you've been keeping up with the protest and a lot of the underaction, Portland is kind of a like a breeding ground for a lot of these ideas and strategies. And for the last several years, Louisville has explicitly looked to Portland as a model for how the urban governance machine can uh, start to change the issue, right? So that's all of that inside of urban heat island. Okay. And remember, urban heat island, we can see the heat distribution from space. We can measure the land cover that's there. And now we've introduced the fact that there's people distributed among that. Okay. And there's patterns. So my work is in mapping, okay, and mapping these things out. And as Dr. Katawati was talking about earlier, you make statistical mathematical models that describe these things, okay? And because if there's a problem, you have to measure it, and then you introduce mitigation strategies, okay? So that's all in the urban heat island, but what else? There are countless examples. And as I mentioned earlier, here we're talking about environmental equity, okay, within the context of environmental justice, but this also falls under other philosophical kind of headings, right? And the conversation is getting more sophisticated all the time. But at the root of it, it's very simple. There are communities of people who are burdened and oversaddled with the waste products, the dirty parts of society. Okay, and here's a few examples that I have. So I'm from further in the south. So in my neck of the woods, we have petrochemicals are have traditionally been among the biggest industries there, and these things are always located in particular places, right? And so in this example, there's a little place outside of New Orleans called Miro, Louisiana, and they have this big uh, petroleum uh, uh, processing facility. So they basically take oil that comes out of the ground and turn it into the myriad of products, that we need. We need them less maybe today than we did in the past, but you have to have them. Uh, but who has to suffer the externalities? Who has to live near these things, right? Because what can happen as a result of Hurricane Harvey in Houston, Texas? They also have a huge presence of petrochemical. So when the floods from Hurricane Harvey came in, the 16 inches of rain over a short term, it just flooded all these places, right? So all that stuff, all that spilled chemical, hazardous gas, just everything you can think of is now in this water. And as a result of the flood, it basically spread everywhere that the water spread, okay? And you could think of any big industrial sites that you've seen. Many of them have the potential to do this. In Florida right now, there's a big phosphate pond that it's somehow connected to I think it's fertilizer production, but there's a nasty byproduct, and they store it in these big ponds, and this pond's about to collapse. Not only is it going to flood a town, but it's going to spread this nasty stuff, over who knows how large of an area. Little bit down the road from that first picture, there's another town west of New Orleans called Reserve, Louisiana. Okay, and it's a little more famous. It's actually known as Cancer Alley, USA. Okay, this is not the West Virginia Cancer Alley. This is another one. Same thing, right? They're taking petroleum. This is actually among the facilities where they wanted to transport the heavy crude that comes from Canada to places like this. You can't really see them here, but there are communities all around here, including down this little street right here. So this is a neighborhood that on, both sides here have this chemical stuff tucked around it. All right. There are places in Louisville that are exactly like this. There's like a Riverview neighborhood, I think, is kind of tucked right in behind Rubbertown. They're neighbors, and the industry is just kind of developed all along them. Okay, well, people are not choosing, to live among that stuff. All right, another famous example, a little more recent, the Flint water crisis, right? So mismanagement of money, and people actually went to jail here for making decisions that disregarded totally the lives of some folks here. So they switched the water source here. They didn't provide the additional chemicals that were needed to counteract some of the contaminants that were in the water, and it leached lead out of the lead copper distribution lines, and the community drank this stuff for a long time before people knew it was a problem. And officials knew it was a problem, okay? And they didn't do anything about it, and they really didn't tell anybody. And it was in fact uh, a scientist from West Virginia who caught wind of this, okay, and he jumped on it. His team, him and lots of them, hims and hers, but they jumped on the problem, okay, and they for these people, you know, took it out there and took on the issue and got all this attention brought to it, and now we all know about it, and people went to jail and all kind of stuff. But there's many communities where exactly this kind of stuff happens, including here in Kentucky. Okay, maybe not the same type issue, but similar issues. And again, it only happens in certain places. Okay, it doesn't impact all the communities equally, right? So again, we're talking about this fair treatment. All right, it's kind of the second part. No group, can disproportionately share negative environmental consequences. Okay. The most famous example in this environmental justice thing, famous because it was used in the litigation and stuff that actually led up to the 1991 laws that actually codified to some degree this principle of environmental justice, though it still has a long way to go, hence we're talking about it today. But Warren County, North Carolina, this area, because of manufacturing 50 years ago, had to create a lot of, I think it was an additive for gasoline, PCB. And, just look at how dirty the machine is, and there's all this residue here. And if you have a worker in there that's doing anything, and maybe it took 1,000 people to run this factory, they were basically all exposed to this dust, and you're breathing it in and stuff all day, and it gave people cancers, right? And again, what's worse is the people running the show, at least to some degree, understood that these risks were there, and just didn't really do anything because of the nature, because of the nature of the area, right? Because of the way the society was run there, and the folks that were making the decisions about where these things could be sited and what kind of activities could take place where. The whole point about redlining is land use permissions, okay, is how you decide you can put this here, build a house here, okay? Somebody was making the decision about where all this stuff went, okay? All right, so what does all that mean? And what does it all add up to? Well, when something like COVID comes along, Okay. Now, yeah, when something like COVID comes along, you have disparate impacts because of all the things, because of where the folks live and the types of things that are in their environment and the quality of their air and the quality of their water. When another external threat, another stressor like COVID hits the scene, it disproportionately will kill people that are in a situation where their environment is overburdened with this waste, right? With whether it's water, air, something in the land, the chemicals. Uh, Life is shorter, and the impacts of things like COVID disproportionately kill people that are impacted by this. All right. So on the schedule, we had census data, and it's appropriate to introduce census data here at this point because that's the uh, that's the authority on how exactly all the population is situated, in our towns and cities or whatever. So you know that every 10 years, uh, by law, okay, by statute, they count all of the population. And they not only count the population, but they count the attributes about them. Okay, so um, male, female, how old you are, what your household structure is like, what your income is. Uh, and then there's even more detailed stuff that even gets into travel times for work, the type of employment you have, sexual orientation, I think is a new one, um, immigration status, country of origin, just all these ways to describe the population. Okay, and uh, the reason, okay, the justification behind this count that happens every 10 years is because remember we're believe a democratic republic, and we elect these folks in the House of Representatives to be our voices or whatever. And so there's like 528 maybe or something like that, and it's supposed to be that there's one representative for every 750,000 people in the United States. So we have roughly 330 million, and there's 500 and some odd of these House of Representative folks, and one of those are supposed to speak for every 750,000 of us. Well, as you know, populations move around, right? We were earlier talking about in urban heat island, some of these cities, okay, like Detroit and Buffalo and these Pittsburgh and Syracuse, their urban heat island is getting smaller over time. Okay, and the reason is because the factories and the neighborhoods where all these people used to be, well, the people have been leaving in large numbers. Okay, so as is indicated on this map, where population leaves, you lose representation in the House of Representatives. In these places where it's green, the opposite is true. So this map shows you right away in relative terms where the population is leaving and where they're headed to. Okay. And, you know, all that stuff earlier about the land code and redlining, this is all a function that really happens when folks are moving around and places are changing. All right. And right now it's like high time exactly for that. And at the same time, these issues in the context of this environmental equity is being acknowledged, and every attempt's being made to try to integrate that into what we're doing. All right. So that's why it's important. So that's the US, right? We do exactly the same thing at the state level. Okay. So the state is broke into all the counties, and we are also looking at, in this case, I'm showing you income distributions, but we could also look at population change, right? And part of the hands-on activity we can do today is I had the idea to look at United States profile, and this is supposed to highlight kind of what the mean individual in the US looks like, and you can compare that to the Kentucky profile. And right away, you can start to see the attributes of Kentucky that differ from whatever that average United States individual is, right? But we already talked about how problematic averages can be, but still, right? It gives you an idea because it shows you how equitable the distributions are, okay? So if we were to work on a project, okay, not to get too far away from that, this is all about the context, okay? The whole why. We're just always measuring and counting stuff. It's always the same. That part of it never changes, right? But what it is that you're trying to get at, that's what you do. So, what is an environmental equity project in Kentucky using census data and some kind of data like urban heat island? What does that look like? Well, here I have an example, okay, a very recent example. Uh, this is from the National Resource Conservation Council, okay, a statewide agency very connected to federal maybe it's a federal agency and they have state areas. I'm not sure which, but anyway, they did this project. All of these dots represent the location of coal power plants. So here's a map, and you have these legends up here, and the legends tell you what all these colors and everything mean on the map, okay? So if we look right here, what they've done is use census data to create a vulnerability index, meaning how vulnerable is the population to bad things. And what could tell you about that? Your income, household structure, age of the householder, um, distance to and from certain things, whatever. They created a score, and that's if you're green, you have low vulnerability. If you have red, you have the highest vulnerability, and the in-betweens are the in-between. So this map here shows you the distribution of vulnerability. So that's one thing that's shown. That's what the colors represent. Here in West Kentucky, I see a big pocket of generally higher vulnerability communities. I see generally the same thing here in Jefferson County, right? And in a lot of the urban areas, I see the same. Conversely, though, out here in the most rural, most country, most forested areas of where we're at, I also see a lot of vulnerability. Okay. Each of these dots show you the location of a coal power plant, right? And what do we know about coal plants? Is they burn coal and it creates electricity, but out of the smokestack, a lot of dirty stuff comes out. Most important one is something called particulate 2.5. It's a piece of dust that is only 2.5 nanometers wide. A nanometer is 1 billionth, micrometer. It's a micrometer, 1 millionth of a meter. So a meter stick, yardstick, right? 1 millionth of that distance. So 2.5 of those, it's a little piece of dust. It's small enough that when you breathe it in, it can basically slip right into the smallest parts of your lung and stay there. And over time, they accumulate. And before you know it, your lung is a big old sack of all this stuff coming out of the coal plant. And even if you're not there to breathe it, what comes up falls back down. So all of the area surrounding these coal power plants, this stuff has just been littering the ground. So every time it rains and the water accumulates stuff, you end up with piles of it. You're out there raking the leaves, you're breathing it in, you're out there playing with your dogs, you're getting it on, you're out there playing football or baseball or whatever, you're getting it all over you, and it's forever, right? They've been burning coal to make power for 100 years, some of these places. So it just builds up day after day after day after day after day after day forever. And that's some of the reason, right? The CO2 is really what we talk about, but the other part of it is just that it's a lot of poisons that come out of this thing as well. And they've done a good job to scrub a lot of this stuff out, right? But most of those interventions are relatively recently, certainly not before the Clean Air Act. So, in my lifetime, so before me, there was no controls. So what is the question here? Is the distribution of these coal power plants more concentrated in the places where the population is more vulnerable? So just have a look first. This map shows those two layers of information. Remember, the red to green is how vulnerable the population is, however they define that, some combination of income, age, etc. Second, the coal plants that we know, at least in the past, were heavy emitters of toxic stuff, right? Do you think the rich folks, knowing this, would hang around there? No, of course they wouldn't. When they're deciding where you're going to put this thing, okay, remember there's a board of people that are going to have to decide where this thing goes, and they don't just willy-nilly decide it, right? So there's a long process. There's a series of codes that have to be honored to set these things right there. This, you know, and then you do the math, okay? Getting back to what Dr. Dharma was talking about earlier, you need a model that describes it. And the math isn't shown here, okay? But this is where, now it's different type map, but it's now vulnerability considering the location of that. So the distribution of vulnerability looks a lot different. Because before here, you're just looking at what the indicators are based on their attributes, how much money they make, where they live, where they come from, that kind of stuff. But here, it's actually showing you, what parts of the state are being most heavily impacted by this, by these emitters. Okay, so so you have a score here. So if you want to ask the question about who is most impacted by the burning of coal for the generation of electricity, here's the answer. Okay, we could do something similar for urban heat island or for any of them whole other problems, right? What was I going to show here too? I had the COVID map. I don't guess I kept it. Let's just look at that real quick. I thought I had saved it. It's the logic COVID. Yeah. So this is it here. This is just imagine as thorough of an investigation as you could possibly do. And here they're not concerned with power plants. Here they were looking at COVID. Okay. And while COVID wasn't an environmental issue, even though some people did try to link it to environmental things like temperature and precipitation, what is true, okay, COVID transmission is a function of the environment that people are in. You probably heard they talked a lot about high risk jobs, so service jobs where you're interacting with a lot of people. Young people, okay, they're extra vulnerable because they have to go to school and stuff. Um, think about all that all took place over kind of the last year and stuff, right? And this has all been tracked over time, and there was actually some pretty disturbing uh, news that kind of come along with it. The most important though is for our sake. So apparently there's an increase in Jefferson County, a small increase of this particular, that one variant. And some people are still getting sick, but almost exclusively all in the state. The people that are getting sick are not vaccinated, right? So the vaccination seems to be so super important, okay? And what this map here shows is if you look on the left, these are the vaccination rates so far. And just look at how the city, Jefferson County, is divided in terms of vaccination, right? So this is completed here. This is dose 1. So this is into it. it's more thorough and maybe even more stark depending on how you look at it. All right, we see some other patterns developing. Okay, uh, but you should really be seeing some patterns here, because a lot of the maps that we view, a lot of them tend to have this very similar distributions each time, right? And these mathematical models really get at that. They quantify that so that then can be predicted. And in fact, last year, 2 years ago, Tori Farrell did a project where she looked at the urban heat island in Detroit, was able to predict the magnitude of the urban heat island based on the socio-economic characteristics of the population. So she could tell how hot it was going to be in the city by looking at the social fabric that was there, as accurately as one could do using land cover. Because land cover is the bowl that holds all the people in however they are, right? The land use, the code. That's what the video redlining was speaking to, is the decisions have been made, and that's why the circumstance have come out like they have. Okay, and that's what we're getting at. So um, let me go ahead and give you this link. Okay, so part one of the hands-on is check this out. Okay, there's that. And tomorrow we're actually going to be talking about ArcGIS more. We're going to be talking about the ArcGIS story map, because that is another option for putting together stories that people can access, like in the form of a website. But for the project, okay, the project that I'm proposing is we're going to develop some data sets that are very similar to this. So here, for example, they've looked at COVID cases and have started to break them down by race. Here they've broken them down by male, female, and some really stark things start to come out. Okay, so these are in percent of the cases. So in general, you would expect, if there were no disparities, you would expect that the percentage of the population in a place that would translate directly into the percentage of COVID cases, right? And then equally numbers of the COVID cases would be hospitalized, and equal numbers of the hospitalized would then die. But none of all that is really the same, right? And you can just look at the differences, right? And they're really stark, even between males. This was actually a big scientific finding, where males, right, were less likely to get it overall, right? Females are way more likely to actually get COVID, but males were way more likely to die from it. Right. And then even this stark difference that you see would have been different across races and across age structures and across neighborhoods. Okay. The urban heat island wouldn't be much different, right? So instead of here talking about the number of COVID cases, we're talking about magnitude of urban heat island, right? How much hotter is it in this area where it's mostly females compared to a place that's not, right? Because if you find a disparity there, that's an issue then that the mitigation needs to be targeted at, because who's impacted? That's who needs to be helped, right? Age groups, no different, right? And this is like the whole, okay, this is current up to today, but this includes like as long as this thing's been going on. And we've known from the beginning that the older an individual are, the greater the chance that they die. But more recently, supposedly anyway, a lot of the cases are with the young folks, because the youngest, up to 11, can't be vaccinated still, maybe. I don't know if that's changed or not. But anyway, apparently there's some new news out today, and I tried to hunt it down before I even got back on this site, but I haven't seen it. It's something to do with mask. So it's possible that when we do our next field trip thing next week, we may all have to wear mask. Uh, so check that site out, and then what? Depending on who would be interested in pursuing this type of project, that would dictate uh, how exactly we proceed. Uh, but remember, you're starting out with the mapping of the land cover, and then inside of that we have the demographics, and that's what we were going to look at also briefly. So just to show. Right, so they count every 10 years, and we're just on the 2020 census, and that data is supposed to be released in its entirety by December of this year. But some of it's slowly coming out. So if you want to know kind of what the average individual looks like or supposed to look like here, these numbers kind of give you an idea, right? So total population, not even 330 million. We may have lost people. Median household income, higher than generally in Kentucky. Poverty rate for the nation, I think, is a little lower actually than Kentucky. Number of people with a bachelor's degree, 1/3 of the population. Unemployment rate, number of houses, and so on. And then other things, right? The distribution of age can tell you a lot about population. This is even stronger of an indicator when you start looking at whole countries. But even within a community, you need a good distribution of all the age groups. If you have all children, for example, that live in a neighborhood, well, they're not really providers and don't have a lot of jobs or a lot of skills. So you can imagine the conditions there would probably be just a little bit worse off compared to a community full of older individuals who have had a lifetime of at least some degree of earnings and that kind of stuff. So just little stuff like that really makes a big difference in a community. And then when these things start to concentrate, it's really stark what you see. Distribution of veterans. So another real important indicator, and so here's a percent foreign born, right? So we're up to 13.7%. So we're a nation of immigrants, as you hear a lot, and that number is only increasing all the time. In Jefferson County, it's very similar to that. Jefferson County grows about 1% a year, and most of that growth, in fact, is from foreign-born individuals. So Louisville is a destination, and it's known very well, throughout the land. It's not quite as famous as LA or New York or Chicago or anything, but increasingly so, thanks to some of the things that we have going on here. And then of course, race is among the most potent of the indicators. And in fact, if you choose this project, to me, once we start looking at data, there's this idea of collinearity. As I already said, a lot of the maps, they look the same because you can measure, some phenomena lots of different ways, and they kind of are all telling you the same thing. So there's really proximate measures, and that's all the different things you can measure versus underlying structures that really dictate how it goes. And that's what environmental equity gets at, is that underlying structure is literally some group of folks that decided we were going to put this poison machine here, right? And they did it, because of the population that was there, and they were less powerful and simply probably couldn't fight it, like you see today, right? Projects get stopped now all the time, but it's because people are so aware, thanks to social media more than anything. Household structure is a big one. Okay, so let me give you that site. Okay, so I want you to look at that. Let me find the chat. All right, and that's for the whole country, for this one I gave you. Now, I won't go through it as in depth, but let's just real quick look at where'd that Kentucky one go? Yeah, there's the Kentucky link, and then I'm going to put it here too. So it's the same, it just now breaks our numbers down just for our state. So right away you can see, as I mentioned, we're a little less educated than the nation, right? They were 33, we're 25. Poverty rate 4 points higher. Median income $13,000 lower, okay? Our cost of living's lower too, so there's some normalization that could happen there, but it's still low. Okay, obviously there's less housing units. Employment rate a little lower than what it said, and a little bit older, right? A little bit older, uh, more veterans, mostly males. Foreign born. Now, the state as a whole isn't as diverse as Jefferson County and Fayette County and Warren County. Okay, so if you look at these guys, they're going to be considerably higher than Kentucky anyway. They stick out like a thumb according to Kentucky. But that's typical, right? The urban environments tend to more reflect the bigger picture more so than the rural areas. Though that's certainly not always the case, right? Because it's in pockets. It's always in pockets. So, okay, what's the point of showing you this? Okay, I propose in my project that we only look at Jefferson County or Fayette County or any of the other counties that you want, but within the county. So the state is divided into counties. The county is divided into census tracts and census block groups. And these are just bigger units inside of the county. So imagine like 200 smaller sections of the county, and each one has like 4,000 or 5,000 people in it, and it's distributed in the same way, right? We get these same values. You know, how many foreign born, how many males, what kind of race, what age structure, what kind of income, what kind of household structure. And we could look at the distribution of that, right? And that's exactly how they arrived at what they ended up calling this vulnerability index, right? So how you would go from these measurements to an index, there's some paper out there somewhere that just gives us a formula, an equation, exactly like Dr. Dharma was talking about earlier, an equation that, because people have been studying this forever and the literature's out there, their findings are out there. So, you know, we're never just learning this from the very, very beginning. We're standing on the shoulders of giants, as they say, and they're already reaching the top shelf and we're just climbing up their hand and starting right there, right? In some ways that's true, to a fault, for better or for worse, but that's somewhat true. Uh, but anyway, you pick and decide, right? That's what research is all about. And then you get an answer. How vulnerable are these people? They're this vulnerable. So that's probably a good place to stop. Well, actually, let me just say that Saturday, as a reminder, when we were on campus last week, we did the globe exercise, and you guys used the lasers here to to actually measure the land cover type. And I just wanted to remind you that the satellites basically do the same thing, except instead of having one little measurement, it'll be a whole image of measurement. So the whole, 32 megapixels worth of measurements, right? So in each image, there could be hundreds of thousands or millions of measurements, just like you took. And that's how we end up with a map that shows us, what the distribution of the heat is. So the satellites are seeing exactly the same thing that little gun was seeing in our hands on. And then we're not going to do it today because tomorrow is all about geospatial stuff. So we have experts that are going to be there talking about their geospatial kind of areas. And I'm going to start off actually with the day and try to let you know specifically what we do within our department in satellite data, but it's going to be also within the context then of this proposed project. So both of my presentations for the rest of this week will continue to speak to this project. So I'm hoping there's at least one person who's interested in the environmental monitoring in general, even if it's not with this attached question regarding environmental equity. And there's a lot of other stuff that I could share. I won't cover it all here, but for folks that are interested in it, we can continue to continue to share. So any questions? I see we'll only have the two of you guys on till the end here. I guess I ran everybody else off. Any questions about projects? Here shortly, I'm about to be preparing emails trying to get at what these projects can look like. So I gave the options a little bit earlier, and they're embedded in the schedule so you can see them. And then today I'll have something that looks like a handout that is an instruction for if you choose to accept the challenge kind of thing. And then once we get going, see what happens, and we'll continue to do next step, next step. All right, any questions or comments? I was gonna check the chat real quick.
Nope, you just answered it for me.
All right, okay, good. Well, all right, we'll be expecting an email from me today. Appreciate you guys hanging out the whole time. And if you need anything else from me, just feel free to text me or email me or whatever, and I'll get right back to you. And then I'll see you back here at 10 o'clock tomorrow.
All right.
All right, y'all have a good night. Thanks a lot.
You too now.